Alright, so now here we're going to do a couple more examples. So, step one is everything to one side. Step two, factor. Step three, set each factor equal to 0. And then solve. Then check. Alright. So we're going to just leave that there for now. First thing we got to do is move everything to one side. So I like to get everything to the left or anywhere that'll give me a positive exponent or a positive coefficient for my squared term. So plus 4r, and minus 6, and there's no number term, so I'm just going to write minus 6 like this. So it's going to be 10r squared minus 2, or minus 21 plus 4 would be minus 17r, and then minus 6 equals 0. Now I can factor it. I make my table, so I set it up, and I need things that multiply to 10r squared times negative 6. So there's only one variable, I'll just use the numbers. So multiplies to negative 60 and adds up to negative 17. So we have 1 and 60, 2 and 30, it's not going to be it. 3 and 20, there we go. The difference of 3 and 20 is 17. So now I just got to figure out which one's negative. Since the 17 is negative, I want the larger number to be my negative number. So if I have a 3 and minus 20, that's negative 17. There we go. So that gives me my box. It's going to have the 10r squared and the negative 6. It doesn't matter which one of these I put it in. I'll do the negative 20 here and the positive 3, r here. And now I factor out. Greatest common factor here would be a 10r, and then greatest common factor here would be a 3r. I mean just a 3. Greatest common factor here is just an r. Greatest common factor here is going to be a negative 2. If they're both negative, you want to factor out the negative number. So that gives me, this is really 10r plus 3 times r minus 2 equals 0. So now I set this equal to 0. So 10r plus 3 equals 0. And I get 10r equals negative 3. So divide by 10 and I get r equals negative 3/10. And then this one, set this equal to 0, it gives me r equals a positive 2. If you plug these back in, that'll solve your equation. So plug the 2 in, you get 10 times 4 minus 21 times 2 equals negative 4 times 2 plus 6. So that's 40 minus 42, which is negative 2, should equal negative 8 plus 6, which is negative 2. So that works. And then if you plug in the negative 3/10, that will work as well. I don't want to take the time to do that, but you understand the principle. And trust me, it is right. Alright, so I've deleted all the extraneous stuff, so now I can give us some room to work on this one. Following those same steps, I'm going to add a 6z to both sides to cancel that out, and minus 15. And I like to write it in descending order, or standard form, so that gives me 9z squared plus 6z minus 15 equals 0. Now, here's a key thing. The first step really should be, and my bad for not writing it before, is you want to make sure that you factor out a GCF first. If you don't, you're going to end up factoring wrong. The algorithm or the way that we teach you to solve this will not work if you don't factor out the GCF first. So quickly look and see if there's anything that divides out of everything. And there is. All of these are divisible by 3, so I have to factor that out. So then what I'm factoring really is a 3z squared plus 2z, it's messy, plus 2z minus 5. So now the blue is really what I'm factoring. So I need to find something that multiplies to negative 15 and adds up to 2. So that's going to be 3 and a negative 5. Adds up to 2. There's my winning pair. So now I set up my grid, or my box. We know that the 3z squared goes here. We know the negative 5 goes here. And this is a negative 3, or a 3x, and a negative 5x. Now I can factor out my GCFs. So the factor here is just 1. It's got to be something. Here, my factor is just a z. Oh, my bad. I wrote x's here. I really mean z's. Just getting the habit of using x's so often. 3z squared, 3z. 3z is my GCF, and negative 5 is my GCF there. So this is really the same as 3 times z plus 1 and 3z minus 5. So now these are what I have to set equal to 0. Z plus 1 equals 0, so z equals negative 1, and 3z minus 5 equals 0. So we got 3z equals 5. Divide both sides by 3, and I get z equals 5 over 3. Alright, so I'm not going to take your time to check the answers, but those are the answers to this problem. You can plug them back into the original. Make sure you plug them into the original problem to see if these two numbers work, which they do. Alright, any questions? Let me know next class.